In this lesson, we are going to talk about functions and the equivalent algebraic expressions. What exactly are equivalent algebraic expressions? Let's say, for example, I give you x minus 1 squared, and I ask you to simplify this one. You already know that x minus 1 squared is the same as x minus 1 times x minus 1. If you don't want to use the shortcut using the formula, you can just expand it like this one. Again, we are going to expand x inside. So I'm going to get x times x is x squared. X times negative 1 is negative x. Then I'm going to distribute negative 1 inside. I get negative x. Negative negative is going to give me positive 1. If I take the like terms together, I get x squared minus 2x plus 1. Now, as you can see, x minus 1 squared and x squared minus 2x plus 1, they look completely different, but they are in fact equivalent. They are the same expressions. Just give you one example. For instance, if I say x is equal to 1 in this form, I get 1 minus 1 squared, which is going to give me 0 squared, which is 0. If I put 1 in this one, I get 1 minus 2 times 1 plus 1 gives me 1 minus 2 plus 1, which is going to give me 0. And they have to give you the same value since they are equivalent. Now, what you have to be careful is that when you are dealing with polynomials which are irrational functions, for instance, if I give you something like x squared minus 1 over x plus 1, to simplify this one and finding the equivalent expression, you have to be careful because it's not as simple as just expanding and simplifying. In these cases, you have to look at the restrictions on the values in the denominator. Remember, the denominator cannot be 0 because number divided by 0 is not defined. So every step that you simplify, you have to express the restrictions. For instance, in example 1, we have f of x, which is 2 times x minus 1 squared plus 3 times 3x minus 2, and g of x is 2x squared minus x. We are to determine whether these two functions are equivalent. To do that one, I'm going to simplify the more complex expression, which is this one, f of x. And then I will see after simplification if I'm going to get the g of x. So now f of x becomes 2 times, if you remember from grade 10, x minus 1 squared is going to be the same as x squared minus 2 times x, and then square root of negative 1 is plus 1. Remember, I'm using the formula a plus or minus b squared is equal to a squared plus or minus 2ab plus b squared. This is coming from grade 10 academic, which your teacher showed you. Now, this one becomes 2 times x squared minus 2x plus 1 plus 3x minus 2. Now I'm going to distribute 2 inside. I get 2x squared minus 4x plus 2 plus 3x minus 2. One thing you have to remember is that at every step of simplifying, you have to state the restrictions. The restrictions is only under the square root or in the denominator of a fraction. We don't have square root here, or we don't have any fraction, so there is no restriction so far. So I'm going to simplify these. There is no x squared here, so I'm going to get 2x squared Negative 4x and 3x gives me negative x, and then 2 minus 2 gives me 0. So this means that f of x is simplified to 2x squared minus x, which is the same as g of x. So we can safely say that f of x and g of x are equivalent functions. The next example is to show that f of x and g of x are equivalent, if they are equivalent. So again, remember, whenever you simplify, you have to specify the restrictions. Now we are dealing with fractions. So remember, the denominator cannot be equal to 0. So I'm going to write the numerator and denominator in the factored form. The numerator is x squared minus 2x minus 8. Since the leading coefficient of x squared is 1, I can use the sum product. So I'm looking for two numbers that the product is negative 8 and the sum is plus negative 2. Those two numbers are negative 4 and 2. So the denominator can be written as x plus 2 times x minus 4. Now the denominator is x squared minus x minus 12. Again, the leading coefficient is 1. So I can use the sum and product. Look for two numbers. The product is negative 12 and the sum is negative 1. So the numbers are negative 4 and 3. So the denominator is x plus 3 and x minus 4. And since the denominator, we have to make sure nothing makes it 0, you can easily see that at x equal to 4 and x equal to negative 3, the denominator is 0. So the restriction at the beginning is x cannot be negative 3 and x cannot be 4. That's the first restriction. Since we have already specified the restriction that x cannot be 4, I can easily and safely cross out the x minus 4 in the numerator and the denominator. So I'm going to end up with x plus 2 over x plus 3 with the restriction that x cannot be negative 3 and 4. In the next example, we have to find or determine the equivalent expression to f of x is equal to x squared plus 10x plus 21 over x plus 3. Again, I'm going to write the numerator as factored form, in factored form. Since the leading coefficient is 1, I'm going to use sum and product. I'm going to find two numbers with the product 21 and the sum 10. Those two numbers are 3 and 7. Since the denominator cannot be 0, x plus 3 cannot be 0, and this is only possible if x is equal to negative 3. So our restriction is x cannot be negative 3. Now safely I can cross out x plus 3, so I get x plus 7, and x cannot be equal to negative 3. So this means that x plus 7 is equivalent to f of x with the condition that x cannot be equal to negative 3. In the next example, again we have a rational expression here, and we have to find the equivalent expression to the one given. Since the numerator and the denominators, the leading coefficients are not equal to 1, we cannot use sum and product. So we are going to use decomposition method. For the numerator, 6x squared minus 7x minus 5, we know that AC is 6 times negative 5, which is negative 30, and B is equal to negative 7. So we have to find two numbers that they multiply to negative 30 and they add up to negative 7. Those two numbers are negative 10 and 3. So I can decompose the middle term, negative 7x, to negative 10x plus 3x minus 5, because negative 10x plus 3x is going to give me negative 7x. Now these two terms and these two terms can package together. So from the first two terms I can take 2x out, so I get 3x minus 5, and the next two terms I just gonna put a bracket beside them. Now you can see 3x minus 5 is common, so I can take 3x minus 5, factor it from the two terms, I get 2x from the first one, and I get plus 1 from the second one. The next one, which is the denominator, is 3x squared plus x minus 10. In this case, we know that AC is 3 times negative 10 is negative 30, and B is equal to 1. We have to find two numbers that their product is negative 30 and they add up to 1. Those two numbers are 6 and negative 5. So I can decompose the middle term to 6x minus 5x. So I can write this guy as 3x squared plus 6x minus 5x minus 10. Now again, these two terms and these two terms together, 3x squared plus 6x, the common factor is 3x, so I get x plus 2, and negative 5x minus 10. I can take negative 5 out, I get x plus 2. Now x plus 2 is common, so I can take x plus 2 from both terms, I get 3x minus 5. So this expression on the top can be written as 3x minus 5 times 2x plus 1 over x plus 2, 3x minus 5. Before I continue simplifying, since the denominator cannot be equal to 0, I know that x cannot be equal to negative 2 because of this term, and x cannot be 5 over 3 because of this term. Now I can safely cross out 3x minus 5 because I already have that restriction of x cannot be equal to 5 over 3. So I end up with 2x plus 1 over x plus 2, and x cannot be equal to negative 2 and 5 over 3. In the next example, I have a square of side x, and I cut out another square of side length 7 centimeter. The first part of the question says express the area of the shaded region as a function of x. Very easy. I know that the area of the shaded region before I cut it out is x squared, x times x. Remember, this side is also x, and this side is 7. Now, when I cut it out, the area of the shaded region becomes x squared minus 7 squared, which is 49. So that's part 1. That's the area of the shaded region. Now, the second part of the question says write the area function in factored form. I know the area is equal to x squared minus 49. Or I can write it as x squared plus 0 times x minus 49. 0 times x gives you 0. Now, since the leading coefficient is 1, I can use the sum and product, give me two numbers, the product is negative 49, add up to 0. Those are 7 and negative 7, so I'm going to have x plus 7 times x minus 7. You could even write this form right away without going through this format, because by grade 10 academic, you already know that if you have the difference of square, you can write it as this form. The formula was this one: a squared minus b squared is equal to a minus b times a plus b, from grade 10. The next part says use both forms of the function to calculate the area for the x values of 8 and 9, and which form is easier to use. The first form was x squared minus 49. Let's call it a. Now a when x is 8, which I write it as a of 8, is equal to 8 squared minus 49, which is 64, minus 49, which is going to give you 15, sorry. And a of 9 is 9 squared minus 49, which is 89 minus 49, which is going to give you 32. Now let's use the other form of the function, which was x minus 7 times x plus 7. In this form, a of 8 is 8 minus 7 times 8 plus 7. 8 minus 7 is 1, 8 plus 7 is 15, you get 15. And 9 is 9 minus 7 times 9 plus 7. 9 minus 7 is 2, 9 plus 7 is 16, 2 times 16 is 32. And we can see that the values, they match, and the reason is that we showed before that these two functions are equivalent. Now, the next part of the question asks, what is the domain of the area function? Remember that the area function was given by a is x squared minus 49. First of all, we know that the x represents the length, so x has to be positive. That's the first restriction. So x has to be positive. And also we know that since area has to be positive, x squared minus 49 has to be greater than 0 because it represents the area. Now to solve this one, if I move this one to the right, I get x squared has to be greater than 49. If I take the square root, I get x has to be greater than 7. So x has to be greater than 0 and x has to be greater than 7, so the result is x has to be greater than 7. So the domain is x in R and x greater than 7.